What if I told you that right now, humanity is witnessing the universe like never before? That we have a window into the cosmos that not only lets us peer deeper into space, but also lets us travel back in time to see the birth of stars, galaxies, and possibly even the first signs of life? Imagine opening with this intriguing question. Within the first few seconds, we immediately capture the viewer's attention by presenting a sense of wonder and discovery. Then, we transition into the promise of an extraordinary journey. In this video, we'll explore how the James Webb Space Telescope, our most ambitious space endeavor to date, is taking us to places we've never been, showing us things we never thought possible. At this point, you'll want to explain just how groundbreaking is. This isn't just another telescope. It's the most powerful tool we've ever built to explore the deepest corners of the universe. It's designed to see the cosmos in a whole new way, revealing mysteries hidden for billions of years. By using powerful phrases like most ambitious and deepest corners of the universe, you're creating a sense of scale and significance. This isn't just about a scientific instrument, it's about humanity's quest to understand its origins and place in the cosmos. After that, pivot toward the personal impact this journey could have on the audience. What does this mean for us? It means that we can now unlock the secrets of how galaxies formed, how stars are born, and perhaps even uncover clues about life beyond Earth. The James Webb is a time machine, letting us gaze into the infancy of the universe, and in doing so, it might just tell us more about ourselves. Close the introduction by laying out the promise of what's to come in the video. In the next few minutes, we'll break down the incredible technology behind the James Webb Telescope, what it's already discovered, and why its future findings could reshape our understanding of the universe. Get ready to embark on a journey that spans billions of years and countless light years. This is the story of the James Webb Space Telescope, and it's just beginning. With this introduction, you're blending excitement, mystery, and personal relevance, key elements to hook the viewer right from the start. Has a history that stretches back more than 2 decades, with its roots deeply embedded in humanity's desire to explore the cosmos. Originally conceived in the early 2000s as the successor to the Hubble Space Telescope, was designed to answer the questions that Hubble could not, pushing the boundaries of what we know about the universe. While Hubble revolutionized our understanding of space, James was envisioned as the next step, with the capability to look even further back in time, observing the formation of galaxies and stars in unprecedented detail. The path to launching, however, was anything but smooth. Development began in 1996, with initial plans aiming for a launch in the early 2000s. However, the sheer complexity of building such a powerful telescope, combined with the need for innovative technology, led to numerous delays and budget overruns. From redesigns to technical issues, Journey was filled with challenges. It became a project that pushed the limits of what was technologically possible. Over the years, the project faced several launch delays, moving from 2020 founders using 30 has initially leave into 2018. And finally, after decades of anticipation, the James Webb Space Telescope launched successfully on December 25, 2021, aboard an Ariane 5 rocket from French Guiana. One of the most unique aspects is its location. Unlike Hubble, which orbits the Earth, James orbits the Sun at a point called L2, a special point in space located 1.5 million kilometers from Earth. This position allows the telescope to maintain a stable orbit while staying shielded from both the Sun and Earth's heat and light. Because of this, operates in nearly perfect darkness, offering an unobstructed view of the universe. The L2 point is like a quiet vantage point from which it can gaze into the depths of the universe without interference. Finally, the name James Webb itself holds significant meaning. The telescope is named after James E. Webb, who was NASA's administrator during the Apollo era. Webb was instrumental in shaping NASA's direction and overseeing the Apollo missions, which culminated in humanity landing on the moon. Naming this groundbreaking telescope after him serves as a tribute to his legacy and leadership in pushing forward humanity's exploration of space. What makes the James Webb Space Telescope truly revolutionary is its design and the groundbreaking technology it uses to explore the cosmos. At the heart, capabilities is its massive primary mirror, which is the largest ever sent into space. This mirror is made up of 18 hexagonal segments, all precisely aligned to work together as one giant light-collecting surface. With a total diameter of 6.5 meters, the mirror is almost 3 times the size of Hubble's, allowing to gather much more light. This is crucial because the more light a telescope collects, the further it can see into the universe. Essentially, is able to detect incredibly faint and distant objects that have been invisible to us until now, but the power doesn't stop at its mirror. What truly sets it apart is its ability to observe the universe in infrared light. While Hubble primarily captures visible light, James operates in the infrared spectrum, which means it can detect heat emitted by distant objects. This is especially important because infrared light can pass through cosmic dust clouds that would otherwise block our view. Think of it this way. Imagine being able to see through the smoke of a distant fire and catch a glimpse of the flame within. That's what the James does when it peers through cosmic dust to uncover the birth of stars and galaxies. This capability allows astronomers to see star nurseries and distant galaxies forming, revealing details that no other telescope has been able to observe. Another major advantage of using infrared light is its ability to look further back in time. Since the universe is expanding, light from distant galaxies is stretched, shifting it into the infrared spectrum. By capturing this light can essentially look back billions of years, observing the universe as it was shortly after the Big Bang. This means isn't just a telescope, it's a time machine, allowing us to witness the early stages of the universe's evolution. To ensure it can perform these tasks without interference, instruments are kept incredibly cold, just a few degrees above absolute zero. This is necessary because even a small amount of heat would disrupt the infrared sensors. The telescope is equipped with a massive sun shield, the size of a tennis court, to protect it from heat and light coming from the sun and Earth. This ensures that can operate in near-perfect darkness, detecting the faintest heat signatures from the farthest corners of the universe. The James was built with some of the most ambitious scientific objectives ever set in the field of astronomy. Its mission goes beyond capturing breathtaking images of the cosmos, is designed to answer some of the most profound questions about the universe and our place within it. Let's explore 3 of its key objectives. One of primary goals is to peer back in time and observe the universe as it was only a few 100 million years after the Big Bang, because light from distant galaxies takes billions of years to reach us. By looking at these galaxies is effectively allowing us to see into the past. Think of it as a cosmic time machine. The telescope is equipped to detect some of the oldest galaxies ever formed, giving scientists a glimpse into the universe's infancy when the first stars and galaxies began to ignite. These observations are crucial for understanding how the universe evolved from a hot, dense state into the vast expanse of stars, galaxies, and planets we see today. This ability to look back billions of years is perhaps the most profound feature of James, offering a window into an era that has never been observed before. James isn't just concerned with distant galaxies, it's also focused on the search for life beyond Earth. One of its groundbreaking capabilities is the ability to analyze the atmospheres of exoplanets, planets that orbit stars outside our solar system. Using a method called transmission spectroscopy, can study the light passing through these exoplanets, atmospheres, and identify the presence of key chemical compounds such as water vapor, carbon dioxide, and methane, all potential indicators of life. This is monumental because for the first time, we can examine the atmospheres of distant planets and assess their potential habitability. Recently, has already identified promising exoplanets that may harbor water vapor, and the telescope is poised to reveal even more in the coming years. By studying these distant worlds could bring us closer than ever to answering the age-old question, are we alone in the universe? Another critical objective is to unlock the mysteries of how stars and planetary systems are born. Before James, our understanding of star formation was limited by the inability to see through thick clouds of gas and dust where stars are born. James' infrared capabilities allow it to peer through these cosmic dust clouds and observe star nurseries in incredible detail, revealing the processes that lead to the formation of stars and planets. These observations will help scientists understand the stages of star formation, from the initial collapse of gas clouds to the ignition of nuclear fusion at a star's core. Additionally, by observing planetary systems in their infancy, we'll provide critical insights into how planets form and evolve, shedding light on the origins of solar systems like our own. One of the most groundbreaking features is its ability to observe the universe using infrared light. Unlike visible light, which is the spectrum we can see with our eyes, infrared light is a longer wavelength that we cannot see directly but can feel as heat. This capability allows to peer through cosmic dust clouds that would otherwise block our view, making it an indispensable tool for exploring the hidden regions of space. Infrared technology is essentially like giving a cosmic flashlight that reveals what lies behind the veils of dust and gas in the universe. To understand why infrared is so crucial, think about the obstacles that telescopes face when trying to observe distant objects. Space is full of dust clouds, especially in regions where stars and planets are being born. These clouds scatter visible light, making it impossible for optical telescopes like Hubble to see through them. However, infrared light behaves differently. Instead of bouncing off dust particles, infrared light can pass through them, allowing to detect the heat signatures of the objects hidden within. This is why infrared technology is so powerful. It opens up entire regions of space that were previously invisible. A helpful analogy would be to compare infrared capabilities to how we use infrared cameras on Earth. For example, firefighters use infrared cameras to see through smoke during a rescue mission. The smoke blocks visible light, but infrared cameras can detect the heat emitted by people and objects, allowing firefighters to see through the haze. In much the same way, uses its infrared sensors to see through the cosmic smoke and reveal the stars and galaxies hidden inside. You might say, it's as if we've been handed a cosmic flashlight that can see through the universe's hidden veils, unveiling regions of space where stars are being born and galaxies are forming. Infrared light also plays a crucial role in detecting extremely distant objects. As the universe expands, light from distant galaxies gets stretched, shifting from the visible spectrum into the infrared. This phenomenon, known as redshift, makes infrared technology essential for observing the most distant objects in the universe. James can detect this stretched light, allowing us to see galaxies and stars as they were billions of years ago, right after the Big Bang. Essentially, infrared vision acts as a time machine, helping us observe the early universe. Finally, ability to detect heat signatures means it can study celestial bodies that emit very little visible light, such as cool stars, brown dwarfs, and even planets outside our solar system. These objects, which would be invisible to traditional telescopes, glow in the infrared spectrum, making the perfect tool to observe them. By analyzing the heat emitted by these objects, scientists can learn about their composition, temperature, and even the potential for habitability on exoplanets. One of the most common questions people ask when discussing space exploration is, why should we care about distant galaxies or stars being born? How does something happening billions of light years away affect us here on Earth? The answer lies in the ripple effect that space missions like the James have on our everyday lives. The technologies developed for space exploration often find their way back to Earth, improving our quality of life in unexpected ways. Like many space missions before it, fuels innovation that benefits multiple sectors, from medical imaging to communication systems. To start, the advanced imaging technology developed has direct applications in fields like healthcare. The precise methods used to align the telescope's 18 mirror segments have been adapted for use in eye surgery, particularly in improving laser techniques for correcting vision. The ability to detect faint light sources and subtle heat signatures in space is similar to the technology used in medical imaging, such as MRI and CT scans. This crossover between space technology and medicine shows how investments in astronomical research can lead to life-saving innovations here on Earth. Another area where technology is making a difference is in weather forecasting. The advanced sensors and imaging techniques developed help improve the accuracy of satellite-based systems that monitor Earth's climate. For instance, infrared technology, which uses to study distant stars and galaxies, is also employed in weather satellites to track heat patterns in Earth's atmosphere, giving us more reliable forecasts. This is particularly important as we face the challenges of climate change. By improving our ability to predict extreme weather events, these technologies help save lives and protect property, making our planet safer. Communication systems have also been enhanced by the technology developed for space exploration. The need for efficient data transmission across vast distances in space led to innovations in data compression and signal processing, which are now used in modern telecommunications. The ability to transmit data back to Earth over 1 million kilometers away has pushed the boundaries of how we communicate, influencing everything from high-speed internet connections to satellite communications. This trickle-down effect from space missions is a perfect example of how exploring the cosmos can lead to advances in everyday technologies. Space exploration also has a psychological and cultural impact on humanity. The discoveries made by telescopes expand our collective understanding of the universe, inspiring curiosity, wonder, and a deeper appreciation for our place in the cosmos. These missions fuel scientific literacy and inspire the next generation of engineers, scientists, and explorers. They push us to ask big questions. Where do we come from? Are we alone in the universe? These questions don't just impact scientists, they challenge all of us to think about the future and our role in it. At this point in the video, we've delved into the impressive capabilities of the James Webb Space Telescope and its potential to revolutionize our understanding of the universe. If you're as excited as I am about what the James Webb Telescope might discover next, from distant galaxies to the possibility of life on exoplanets, then don't forget to hit that like button and subscribe. By subscribing, you'll stay updated on all the latest cosmic wonders we uncover here at Exploring the Universe. Plus, we've got so many more exciting journeys through the stars coming your way. May have only recently begun its mission, but it has already made remarkable discoveries that have captivated scientists and the general public alike. Some of its first images have provided breathtakingly detailed views of distant galaxies and stars that we've never seen before. Take, for example, observation of the Carina Nebula, one of the most stunning regions of star formation. The images reveal intricate details of swirling cosmic dust and gas illuminated by the radiant light of newborn stars. Imagine the most vibrant, colorful cloud of cosmic dust, like an artist's palette, splashed across the vast canvas of space. The glow of these young stars embedded within the dust provides a glimpse into the birth of solar systems much like our own. Another groundbreaking discovery came from Deep Field Image, which captured galaxies from over 13 billion years ago, just a few 100 million years after the Big Bang. These galaxies appear as tiny, faint smudges of light, but they hold the key to understanding how the first galaxies formed and evolved over time. The fact that we're able to observe such distant ancient objects is a testament to the telescope's unprecedented power and precision. These images are not just snapshots of space, they are windows into the universe's past, allowing us to see cosmic structures as they were billions of years ago, has also contributed to the study of exoplanets. One of its first major achievements was detecting water vapor in the atmosphere of a distant exoplanet. Using its infrared capabilities, analyzed the light passing through the planet's atmosphere during a transit, identifying key molecules that might suggest the potential for habitability. This discovery has reignited the search for life beyond Earth, as scientists now have a more powerful tool to examine the atmospheres of planets that may harbor life-supporting conditions. As we look toward the future, promises to be at the forefront of some of the most exciting discoveries in the history of space exploration. While its early findings have already revolutionized our understanding of the universe, the true potential lies in the unknown, in the questions that have yet to be answered. What will uncover in the next few years? Will it provide definitive evidence of habitable planets beyond our solar system? Can it reveal the elusive nature of dark matter or dark energy, forces that make up most of the universe but remain largely mysterious to us? These are the questions that will drive future research and keep us on the edge of our seats. One of the most anticipated areas of discovery is the search for habitable exoplanets. With ability to study the atmospheres of distant worlds in incredible detail, it may be only a matter of time before we find planets with conditions similar to Earth. Imagine the moment when detects water vapor, oxygen, or even more complex molecules on an exoplanet, signaling the possibility of life. This could be one of the most profound discoveries in human history, the realization that we are not alone in the universe. The idea that could one day help us pinpoint the location of a habitable world is both thrilling and humbling, and it keeps scientists and enthusiasts alike eagerly awaiting the next big breakthrough. In addition to its exoplanet research, has the potential to solve some of the most profound cosmic mysteries. Take dark matter and dark energy, for instance, two phenomena that make up roughly 95% of the universe, yet we know almost nothing about them. Could provide the first concrete clues as to what dark matter is or how dark energy is driving the expansion of the universe. As observes the distant cosmos, its precise measurements of galaxy movement and structure may help scientists piece together the puzzle of these invisible forces. If can shed light on these mysteries, it would fundamentally reshape our understanding of the universe. Beyond that, may also uncover new insights into black holes and their role in galaxy formation. By studying the light bending around these massive objects and observing the behavior of matter falling into them, could reveal new details about the nature of black holes, pushing the boundaries of our understanding of gravity and space-time itself. The potential to contribute to groundbreaking discoveries in theoretical physics is immense, and its findings could have implications for the future of science well beyond astronomy. Looking even further ahead, JWST's discoveries will likely pave the way for future space missions and technologies. As it maps the cosmos with unprecedented clarity, it could identify new targets for exploration, planets, stars, and galaxies that future missions will visit. Its data may influence the next generation of space telescopes, perhaps even more powerful than JWST itself, enabling us to push the boundaries of human exploration even further. As we near the end of this incredible journey exploring the James Webb Space Telescope, it's important to reflect on the significance of what we've discussed. The discoveries made aren't just about gathering data, they are about seeking answers to the most fundamental questions humanity has ever asked. Why are we here? How did the universe begin? Are we alone in the cosmos? As we continue to explore the universe, we are not just seeking knowledge, we are seeking to understand our place in the cosmos. These profound questions go beyond science. They speak to the very essence of human curiosity and our desire to explore the unknown. Term, er en fame we see search and